Hey Jan, this is Kevin giving you the answer to the homework question that you submitted. So you're asking about the time it takes for a person to climb up an escalator, and it gives the parts that go into this. It gives the amount of time it takes for a person going on a moving escalator, so that person's not moving, just the escalator, and it takes 27 seconds to go all the way up. And then it also says that the person walking up a broken escalator takes 13 seconds. So how do we relate these? Well, if you think about the speed, if I was walking down the street and I was walking at whatever speed you want to give me, and somebody came up behind me and started to push me so that I was going now faster, the speed is essentially what I was doing plus what they're now pushing me at. So that's a good place to start. Let's write that down as an equation. So let's talk about the speed. The speed of both of them is equal to the speed of one of them, let's say the escalator, plus the speed of the other, which would be the speed of the person. Let's draw that out to the side. Just the person going up the escalators is essentially just walking upstairs. And that's their speed, the speed of the person. We'll give them some little action marks so we know that that's all moving. Otherwise, if the person is just simply standing on the escalator, and the escalator is the one that has the speed, right? Now it's the escalator that is doing all the moving, and the person is just standing there. So, now this is all just a good place to start, but how does this relate to what it gives us? It gives us time. And speed does not, there's no time in this equation. So we have to look to see if there's a relationship we can use to our benefit. Well, let's think about what speed is. Speed is distance over time, right? Sometimes what we use to measure speed would be like miles per hour, where I'm going a certain number of miles every unit of time, hours. So I can take each of these and I can replace it with distance over time. I just have to make sure that I'm keeping the same discussion, the same notations. The distance of both equals the distance of the escalator travels over the time it takes the escalator, plus the distance of the person over the time it takes the person. Because each of these becomes the speed. Okay, what's the next line down? Well, I've got a lot of distances here described. The distance of the person, well, the person's climbing to the top of the escalator. The distance of the escalator, well, the escalator also goes up to the top of the escalator. And then if they're both going at the same time, they still go up to the escalator. So if I wanted to write this all out, I could essentially just replace all these d's with the same d. And then look at that. The distance that each of these travels is the same. Well, I've got d's on both sides. What if I was to factor out a d? I'm looking at factoring out a d. My mind here is thinking of factoring out the d because it's everywhere. And if it's everywhere and I can get it outside the parentheses, well then I can cancel it. And it looks like I can do that without a problem. So I'm going to factor it out of each of these terms. That leaves a 1 where it was on the top of the fraction. And now I can divide both sides by d to cancel that out. That leaves me with the time of both, 1 over to the time of both, equals 1 over the time of the escalator, plus 1 over the time of the person. Now I want you to keep in mind this one right here, because this is a very, very important equation. This works with the relationships of rates. I've seen this problem whether you're talking about the amount of time it takes for a dehumidifier to take away the moisture from the air, if there's a certain amount of air that it's filtering through. There's a lot of different ways that we can use this equation, but this is how we get to it. So let's keep going now that we're here. So I've got the time of the escalator, the time of the person. Well, these all are things that I remember the problem giving us. If we go back up to the top, it looks like the time of the escalator, the moving escalator, was going to be 27 seconds. So let's plug that in. The time of both is 1 over the time of the escalator, which we know was 13 seconds? Nope, 27 seconds. 27 seconds. And then the time of the person was the 13 seconds. Let me double check that to make sure. And yeah, 13 seconds. Well, there we go. Now the thing is, I don't have time 1 over time b. I can either take care of that now or I can take care of it later. I'm going to choose to take care of it now and just invert both sides. Invert just means flip over, and I can do that by putting a -1 on the top. And now what do I have? Well, I have tb equals 1 over 27 plus 1 over 13 to the negative first power. Look at that, I was able to flip this over. This became tb over 1, which was just tb. And then I've got 1 over 27 plus 1 over 13 to the -1. Let me pull up my calculator and we'll type that in. So 1 divided by 27 is going to get me something along the lines of 0.03. 1 over 13 gets me 0.0, or what we get, 0.077. Give myself a little more room here. This is all equal to TB. Let's combine that. That gets me on the inside here a, let's see, 0.114 to the negative first power, and finally to the last step. A little too far. If I was to flip this over, I would get 8.78 seconds. I'll put a little squiggly mark there because there's a lot of decimal points, and putting a squiggly mark means it's almost equal to 8.78 seconds, but I don't feel like writing that many decimal points, so I am just going to box this as my final answer. I'm going to say that it takes 8.78 seconds if the person and the escalator are working together. And then let's go to the top and make sure that that makes sense. 8.78 seconds is less than it took just the escalator and less than it took the person alone. I think it passes the gut check. So that's the answer that I'm going to submit to my teacher, and that's the work that I'm going to show. Let me zoom out so you can have this for your notes. That's everything we worked with. Have a good one.